This is, I think, a very, very special opportunity. Of course, we have Josh Long. Who doesn't love Josh Long and a Josh Long show? So Josh Long is going to kick us off.
Okay, please.
But then we're going to be joined with Dr. Rod Johnson, the first founder and creator of the Spring. So this is amazing, a really amazing opportunity. And of course, Dr. Mark Pollack, who has also created very important Spring projects, including the Spring Cloud Data Flow, Data, and Spring AI, of course. So you have the creator of all of that here.
You're not?
So this is going to be a very special presentation. Are we ready to go?
Oh, the screen.
Oh, we got to plug in.
Wow. I've never done this before. I'm new.
Okay. Off you go.
All right. Guys, come on. Okay, first things first. Priorities are very important. Let's get a selfie before we go. Come on. Okay, I just pretend like you're happy. Gee, just smile. You're going to be okay. It's fine. Okay, ready? I got 2 doctors and adults, right? So this is good. Okay, ready, steady, say open source.
Open source.
Oh, yeah. All right, look, we don't have a lot of time, so let's dive right into it. That's Dr. Johnson, Dr. Pollack, and me, Josh Long. Nice to meet you here. Look, you were going to talk about... you were going to talk about something. Yeah,
you going to talk about something.
Yeah, you go.
Am I on? Yeah, I'm gonna start. I'm gonna kick it off. So I did create Spring. First lines of code that went into Spring was back in 2001. So quite a large part of my life, but it's also been quite a long part of my life that I haven't been involved in Spring. So haven't really done daily work on the JVM for probably until the beginning of this year, 12 or 13 years. I got borderline obsessed with Gen AI about a year ago. And I have to admit, I was in the gutter. I was doing Python. I was coding loads of Python every day because I thought that's what you have to do Gen AI. So given that I was trying to build a fairly complex system, Python's really good for some things, but it is not good for building complex systems. So I saw Spring AI, which was very new at the time, and knew that, well, my friend and former colleague Mark is behind this. It's going to be good, but also it's Spring, so obviously it's going to be good. And I switched to the JVM. Since then, I have not looked back, and it's been awesome. So, one of the things that I would like to say to set the stage is don't let anyone tell you if you're a JVM developer, you need to switch to Python or TypeScript to do Gen AI. Because that's total nonsense. And I mean, trust me, I've written a lot of Python. I am extremely fluent in all the Python projects out there. There's good stuff in Python, but you don't need to switch to it. So if you look at the future of making AI useful, there's a massive gap between brilliant demoware and reality. So certain scenarios, like, for example, a personal assistant, ChatGPT and Claude, are really, really good. But you don't care if they get it wrong 10% of the time, right? You just laugh at it and move on. You can't build enterprise systems on something that has 1/9 of reliability. So getting from that promise of Gen AI to reality, I believe that's where the JVM and the skills of JVM developers are going to be incredibly important. Because we are really the people that make hard stuff work. I mean, the world runs substantially on the stuff that we build. And it's complicated stuff, and it's not demo stuff. It's real stuff that moves money, that affects the world. So, I would say that not only is Spring AI an awesome solution and getting better every day, but the JVM is a platform on which much of the future of Gen AI is going to be written. Secondly, why Spring? Well, Spring has been around pretty much forever. In AI terms, I went through university, went through computer science in what is now referred to as the AI winter. Our head of department at Sydney University was one of the few people who believed, and he used to say cynically that AI is the set of things that doesn't work. If anything works, they say it's not AI. So, they used to say, oh, if you can make checkers unbeatable, that'd be AI. And then they did that in, I think, 1962. And then they said, well, do the same for chess. They did that in 1997. And people said, well, that's brute force. It's not really AI. So we're clearly in a different place with respect to AI, but it turns out that a lot of the core things that Spring does are extremely relevant. Back in the early years of Spring, we used to talk about what we called the Spring Triangle: dependency injection, AOP, and portable service abstractions. Those things are equally relevant today, but in fact, if you look at Spring AI, you see just how powerful and how relevant those concepts are to the Gen AI space. So obviously, dependency injection enables you to configure things easily, especially if you're using Spring Boot. The Spring container also enables you to expose functions absolutely trivially, which is very, very cool. Portable service abstractions. There are a lot of different LLMs out there, and there is a lot of subtlety in how they talk, and Spring AI does a really good job of trying to bridge that so you get a consistent experience for function calling, and a consistent experience for, embedding models, all these kind of relatively low-level things. And finally, even AOP turns out to be highly relevant. And if I have time to do my demo at the end, I'm going to demonstrate just how awesome the notion of advisors is. It's a little bit like the interceptor chain in Spring AOP, and it's a very powerful way of essentially decorating LLM interactions. So I think Spring AI is a really big deal. I'm delighted that Spring is playing a leading role in the Gen AI charge for the JVM. I think it's going to be really exciting.
Awesome. Thank you, Doc. That's all you.
Okay. So I'm going to set the stage a little bit with some background information, and then we're going to jump into a bunch of code. Normally, we kind of go back and forth with diagrams and code, but I think here we'll focus more on the code. And as Rod was alluding to, nothing is created in a vacuum. We're standing on the shoulders of giants. This field goes back to the 50s. And I think I started paying attention maybe in this sort of deep learning phase. I mean, I'm not an expert in this. I casually read. And this is the deep learning phase is impressive in that, that's what was able to not just do chess, then eventually beat grandmasters in Go, which is, much more complicated mathematically if you were just doing some kind of raw search space. And also, this is when they learned to teach video games. They started off with playing the Atari 2600. And that same algorithm that can play chess is the same thing that plays Breakout, right? So it's not one algorithm per game. It's an algorithm that solves all of these problems by doing deep learning. So lots of training to do goal-oriented learning for neural networks. But now we're in this generative AI phase, and there are many, many distinctive features about this. It really is a unique and interesting phase. Oops. I'm sorry. So one of the big takeaways is that you interact with this using human language. And it's actually impressive if you just take a moment to think about it. This is any human language, right? Not just English. It's all of them, basically. And the other important factor, thank you, is that they're pre-trained models, but they can generate data. And so that's distinctive from the previous generation, this ability to generate new data without new training. And you can guide the model to give output that's contextually relevant for you. So if you saw the keynote, we created the persona of owner of a pet shop, and this pet shop would respond in a certain tone. So you can guide it to suit a sort of human persona. And part of this idea of not needing to be a data scientist, in large part, is because you don't have to train the models anymore, they're pre-trained, but there's a very simple, accessible web API. So all application developers across all languages can now write these apps. And they don't depend on libraries, in particular mathematical libraries that usually run better using Python because their bridge to C is so efficient. So these are like the storm, I guess, of features kind of really culminated together when ChatGPT was launched. And these are the things that make it particularly unique. There are many use cases. I think really, you can't, it's going to touch everything, right? Sometimes it's kind of stupid, like I went to buy a battery charger on Amazon, and it literally said AI port, and it was just a USB port. You know, like, really? You're really, marketing team, you're going to lie that much? But yeah, people do, right? So search and summarization, this is like, I think, the bread and butter. You have lots of documents, and you'd like to efficiently get them summarized. Can you imagine what it would do for the legal field? They sit and read, briefs that are like so enormous. And searching, finding that needle in the haystack that's contextually relevant. And software development, that's what I originally got into, doing code generation using AI. It is effectively like another language, like French or Spanish or English. It understands all the languages and all the frameworks that go on top of it. Incredible achievement. So for the enterprise, really, how do you apply generative AI? It's really this cycle of life that you wanted to know about your corporate data and your corporate APIs that it has not been trained on, because hopefully you haven't given them data unknowingly to train. And in fact, there are stories that companies are very concerned about leaking. In fact, most people here who have a corporate laptop probably can't even connect to ChatGPT because people are so afraid that your precious IP will be stolen or trained and then disseminated out through the model to the general public. So how you go about doing this, bringing your data to the model, and how the generative model can in turn call your application to get more relevant answers, this is, I think, the key circle of life for creating generative AI app. And what's good about this is you can view it through the lens of being an integration problem. And Spring is great, has tons of modules that connect to everything, right, in terms of data. So you're very well covered in the Java space for doing that. And Joshua will build this up over time, and we'll talk a bit about how to pick models. We have a demo on that. It's kind of an underappreciated part. But these are kind of the four, let's call it, sectors. And you have your data and your apps on one side. And then you have this concept, technology, called vector databases. Right now, this is critically important to have if you're trying to summarize or search documents. You basically have to pre-process them in a certain way. The reason is there are technical limitations and cost limitations about how these models work. So if you have, all the, reports from your internal reports from your company, maybe this is, 3 gig. You can't send 3 gig over to the model and say, figure it out. You kind of have to do some data engineering up front, and that's what the vector databases are for. And then the bottom right, you have models. There are many companies that have models. Within each company, there are many variations of the models. Models can run on cloud, they can run locally. So there is a selection process there, and you have to get familiar with some of the terms and terminologies. But one of the best things you can do, and we'll demonstrate this, is to try out the models and get a sort of vibe check, right? Have some domain expert or pick a topic that a developer could also in principle be an expert on, right? Because it's not too outside, it's not pretty mainstream. So you have to bring all these things together. And one pattern, one way to do this is literally starting with batch jobs and documents, right? Doesn't sound very sexy, but that is how the sausage is made. And you load this data, could be a variety of formats, PDF, could be code, images. You store them in this vector database, and now you have your app. Your app now takes, the user input, queries that to find supporting data, and sends it off to the model. And what we've provided is a way for you to easily plug and play any model with any vector database. And in fact, we created a SQL-like query language that unifies all the query languages of all the vector databases, which are completely horrible, horrible, horrible SQL things. I never saw a select statement that had more underscores in it in my life. So the one thing that's interesting and not very obvious from this slide is this bidirectionality at the bottom. What this means is models now have this capability called function calling. Essentially, in colloquial terms, it's like it reasons that it needs some information, and it knows in the back of its head it has these functions like get temperature and zip code. And it says, oh, I could solve this problem if I called that function. And then it does. So it's not done replying, it's doing a step in replying, which is calling your function. sends the information back, and goes on and on and on. Maybe calls 3 functions, 4 functions, 5 functions. When it's finally done, it takes us all that data and synthesizes a response. So that part, the function calling, is incredibly powerful. Can't be underestimated. And normally when we do this talk, we don't have as many people, and we kind of go over these challenges, right? These are kind of really technical limitations that end up defining your architecture. And so the first one's easy to understand. I think we'll get a quick demo of that after choosing a model. It's basically how do you align the model to act in the persona you want. And there's a system prompt, that's the technology part of the solution that you would have to tweak to give it the right persona that's good for you. And we're not gonna go through all of them in the demos, but I'll just highlight maybe 2 more, right? One is called limited context size. This is probably one of the most important things to be aware of. Context size, let's just call it the amount of words you can send. You can send it 100,000 words, no more, right? So what do you do if your document is bigger than 100,000 words, right? You have to send it only the relevant parts, and that's where the vector database comes in, essentially to give you the first page of Google search results for your document, and that's the information that goes over. And that's where this concept of retrieval augmented generation comes. Because you retrieve the data, you augment the prompt literally by string concatenation, effectively, and then you pass it off to the LLM to generate. That's the acronym. And the last one at the bottom, hallucinations. We provide very basic evaluator support, but you need some way, whether it's a human or some automated way, to figure out, is this solution right? And that, I think, is really the trickiest and maybe most difficult part right now, is you made it wiggle, but did it do the right thing? And going through that loop is an important step to going into production. So I think, yeah, I don't take any more time. I'll hand it over to Josh. I don't know if
Okay.
we're going to do this part together, or?
Well, yeah, the first part, certainly.
Yeah, the first part. Okay.
Okay. So let's build some code, as always, by going to my second favorite place on the internet. Anybody who knows me knows what my first favorite place on the internet is. What?
Production.
No, oh, it's all wrong. It's just all wrong. Table flip. No, it's production. My second favorite place on the internet is start.spring.io. If you suffer from indigestion in the early morning, start.spring.io. If your eye is not intelligent enough, start.spring.io. And if you're restless and cannot sleep, start.spring.io. So we're going to build a new application here, friends. We have to make some decisions, of course. What do we want to call this? I'm going to call it AI. I'm going to use Java 21. Super important. I talked about this in the last talk. Java 21 brings with it the ability to do virtual threads, so you're not blocking when you do I/O. Guess when you do a lot of I/O? Talking to any model, anywhere, at any time. We'll do lots and lots of I/O. Trust me, this virtual threads couldn't have come at a better time. It is perfect for the AI era, and it's a lot more concise than competing languages like Python and JavaScript and whatever. Okay, so we have a couple things. GraalVM, of course. We want a model, like an LLM or a model, a chat model. We have a lot here. We talked about, we've got Gemini, we've got Azure, OpenAI, we've got Ollama, we've got Hugging, Amazon, Amazon Bedrock, and of course, we're going to use OpenAI, but as you'll see in a bit, it's trivial to switch out thanks to the power of portable service abstractions, about which Dr. Johnson just spoke. We're going to use OpenAI. We need a vector store to make similarity searches, to make it easier to sort of winnow down the results a bit easier. I also want a database, so that'll give me a 2-for-1. I'm going to use this. Do I want Spring Data JDBC? Probably just JDBC. No, actually I want Spring Data JDBC. Let's get that in there as well. Anything else? Web support, surely. Actuator. We want Zipkin for distributed tracing. Anything else? I think that feels like...
I don't remember what else is needed for observability.
Yeah, I think that'll do most of the work for us. Let me just check the old note here. I mean, the nice thing about this is that it's trivial to come back and add it later. Oh, by the by, if you want to stand up all this stuff for yourself, just choose Docker Compose. It'll automatically give you a PG vector, Zipkin, it'll give you a container, Docker Compose file for all that stuff, okay? But I've already got that running in the background, or at least I'll just keep it. Let's hit enter. Okay, and we go to terminal, downloads, uai.zip, okay, AI application, there we go. So a couple things we want to support. First of all, we have to make a choice about what model we're going to use. We already we already made part of that selection by choosing the starter,
Right.
didn't we?
For OpenAI. But
Right.
in OpenAI, there are many models.
Right.
And their cost structures are very different. Some models could be 10 times cheaper than others.
So, by the way, can you turn on his microphone?
Oh, sorry. Is it not on?
Is his on?
Oh, sorry.
Yeah,
I'm
okay,
going
there
to
you
move it up a little bit.
So obviously, I talked about this before, but you need to specify the OpenAI key. Again, I've already done that offline in an environment variable. Now you need to specify the model, right? So let's say I choose GPT-4o Mini. Why would I choose Mini over 4o?
Cheaper.
Okay.
Maybe just as good.
So let's just do a simple demo here just to see, because you talked about a paper, right? What's that paper? Vibe something?
Oh, well, vibe check.
Yeah.
Yeah, no. If you have,
Vibe checks are all you need. Is that the paper or the?
that was the title, yeah.
Oh, the blog. There's this idea of a vibe check, right? This one. Hopefully, I'm not getting spam. Yeah, this looks right, right? So basically, you want to talk about that while I code?
Sure. So the idea of a vibe check is as casual as it sounds, right? It's that you get the output and you kind of glance over it with your human intuition and say, this seems kind of like what I want. And sounds so basic, but people don't do this. It's really shocking. They're just so happy that the thing answered, they just go on their merry way. So this is can be automated, right? And you can use LLMs as judges, and that's where you get more sophisticated. But in the beginning, you kind of just have to feel things out, right?
Okay, I'm gonna get the content var reply, and I'm defining a bean of type chat client. Again, pretty straightforward if you've used any of our other clients in the ecosystem, obviously. We've got the REST client, the JDBC client, the web client, etc. And I'm asking it a very simple, straightforward question, to which I'm sure it probably has an answer. The question is it a good answer? And you and I, heuristically, we probably know the answer. We know what a good one looks like, right? So let's just run that.
Okay.
Yeah.
I haven't seen this one before.
Well, I don't know.
Let's take a look.
Waiting for it. So it took a long time, because remember, that starts on startup. You don't want that delay happening in your production code, so make sure you do that. Okay, so occupy, okay, there you go. Reply 1, occupy and control the central squares for greater mutability, develop. I don't know. Is that okay?
That looks pretty good.
Okay.
What, switch it to 3.5 Turbo.
Is there, wait,
The
3.5
worst
Turbo?
model.
Oh yeah, 3.5 Turbo. Okay.
That was so bad.
Is this one?
It
Is this
used
the right
to be
one?
the darling child.
Is that the model?
I think so.
Okay.
If not, it'll just blow up.
So even within the same provider, it makes sense to do a little bit of comparison shopping, is I guess what I'm trying to say. Oh, you know why it's taking so long? I've got the Docker Compose stuff starting up in to no avail here in the background. Let's see. Okay. I don't want it to do that each time. Docker Compose up. Here we go. Fine. Okay, good. So did we get a response of any merit? I don't have access to it.
We're guessing the wrong enum.
Okay.
I have to take a look at it.
Here we go. Don't worry, we have the internet. Do, 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 do. Text embedding 3 small? No.
Oh, no.
3.5. Well,
You need to go to the API documentation.
okay. API docs.
Or just
Open.
OpenAI, yeah?
Yeah. You know what's ironic? The one thing that OpenAI is not particularly great at is answering these questions about its own documentation. Turbo. It looks like it should be that, right? GBTI. Okay, this one.
3.5. We forgot the dot.
Just, okay, I can do that. I can fix this. Just like the Blue Man Group, we're live. Okay, so that was...
Yeah, so this is a good example, right? This is clearly not enough, right?
All right.
So the other one looks better at first glance. Right?
So, yeah.
Something as simple as that is what you need to do.
Okay, so let's get back to... I think we're going to settle for 4.0. Is that okay with you?
Sure.
Yeah.
Let's burn as much money as we can.
Yes. Okay, so we got a very simple example. We got the client. I'm using this chat client. The chat client is your interface to the model. We talked about where there's actually a model that's being configured by the specification of those properties. There are many models, and this is just for chat, but there's actually image models. What other models do we have?
Yeah, you can upload video.
Video
They
model?
call it multimodal.
Yeah.
So you can actually send an image and ask what's in the image.
So Spring AI
Features
supports
like
all
that.
Yeah.
Yes, as much as the models do.
So we got a chat client. I think I'm happy with this. You can see it's pretty easy. You make a prompt, you specify a user prompt and or a system prompt. And typically, you can do the system prompt up here, you know, in a single place, right? So you can have a default system prompt, and this sets the tenor, the tone, the overall sort of frame of reference for answers you get from the model. It precedes any other commands.
So speak like a pirate.
Oh yeah, okay. Speak like a pirate. Yes.
And run it again.
Oh. Why? Why does that matter? Okay, here we go.
Yeah, you see?
Checkmate your opponent's king, so it be having no safe squares. Control the center of the board with your pieces. Protect your own king. Keep it safe from check. Yeah, you get the idea. You can do all sorts of things with that system prompt, okay? So that's a very simple example of using the chat client. Now, the chat client, of course, is your interface. You can ask it to give yourself responses back. For example, I might have a type up here. I might say record list of steps, right? And then list of string steps. Do you think that'll work? Probably. We'll find out, right? And I can ask it to give me back this thing in a structure that kind of makes more sense for my code. This is a bit of a contrivance, but let's just try it.
I think the toString is gonna...
Okay. So there you go. It says steps, control the center. Well, it gave me one big string in the array, but you know, it'll do a pretty good job usually. You can actually get it to give you...
I thought you had another demo with the
joke
converter. No, I don't know. I thought...
Oh, the structured output converter. I just did entity.
Yes.
Yeah. So you want to do which one?
I don't know.
You could provide your own structured output converter?
No, I just meant, thought you had already another demo that was doing.
No, just this one. I was going to do a joke.
Okay.
Okay, good. So we got the response. Okay, moving on. Now, we've got that structured output. Obviously, we want to be able to connect our model to our data. You saw this demo, I'm sure, a few times, but let's revisit it. I've got a data source here on the background. At least I think I do. It should be running. Hopefully, it's connected. I'm going to connect to it, right? Data source, JDBC, PostgreSQL, localhost, my database, and the username. Oh, dear. Username is my user, and the password is secret. Please connect. Go, connection, apply, okay. So I've got a table here, hit refresh. My database, tables, I don't know what all that is. Drop everything. Okay, and I'm gonna go back to the command line here, cd desktop talk init database. Come on. Cat. Dogs.sql. PG password equals secret. psql u my user my database h localhost. Okay, there we go. So now I have a table here. Refresh. Table. I've got one table full of good and bad dogs, and we want to find this guy Prancer, right? We saw this demo before. So what I want to do is I want to convert to RAG, retrieval augmented generation. You want to talk about that for a second?
Yeah, sure. So this is the step where you would usually take a very large body of data. Here it's simply kind of contrived, right? It's not a PDF of 1,000 pages, but the steps are the same. And you convert them into what Spring calls a document. Document has text, can also have images, but here is just text. Essentially, it's this row is going to create a record that represents a row. You just read them in, so you could read them in through any Spring Data mechanism, right? If you have it in Mongo or if you have it in Neo4j or whatever your data repository is, you can just use Spring Data, JPA or JDBC in this case, to read those records and now shove them in the vector database. There's usually also a step which is chunking, which we won't get into. Like, you can't put a document in that's, for example, bigger than the context window of your AI model because you overflow the bucket, so to speak. So here's just showing you the first step of importing, right? And you don't need fancy ETL tools, or you're free to use them if you want, but it can be as simple as this.
So I think that's okay. So I'm going to read through all the dog records in the database. Then I'm going to add them to the vector store. Now I'm going to ask the chat client if it has any, do you have any neurotic dogs? And this is the bit that Dr. Johnson was talking about earlier. We have this advisor mechanism. So I can inject a question answer advisor here, point it to my vector store. And by the by, another nice thing that just happened this morning, because, living on the edge, if you go to start.spring.io and choose to generate a new project, you get M2, which is nice. So that'll actually work. Okay.
If you want to take a moment and open up the question answer advisor class.
Yep.
So what this is doing is it's a chain of events that's happening before the user text hits the LLM. And so think of it like SQL injection, but for good. Open it up again. So we're adding this text, literally doing a string concatenation, and we're going to replace the information that we retrieve from the vector store in that placeholder. So that's all it's doing. It's just doing this, augmentation of the prompt, and now it uses that as the basis for considering a response over its pre-trained knowledge.
Did I not? Do I have Postgres?
Relation dog does not exist.
It's a Spring Data JDBC, dog repository, dog, integer ID, name. Is that the right credentials? It surely must be. Postgres might.
Yes, you connected already,
Okay.
I think.
Well, I feel very silly. My database at localhost.
Unknown source.
Dog ID is name, description from dog.
What is the repository finder method? Find all?
Yeah. It's what?
Relation dog doesn't exist.
Yeah, but unless I'm crazy, it does. No, it's JDBC, right? Which? Oh, is that not a list repository? Okay, let me change that. This is here, and that's there. I wonder if that makes a difference. Surely not. Dog repository, interface dog. Is this the right ID? Oh, vector store doesn't. Okay, we're making progress. Good. So we want to initialize the vector store. True. Please go faster, faster, faster. And now Zipkin isn't working. Docker. Don't worry, I'm a trained professional. I have had things flounder before. Containers. Goodbye. Goodbye. Go here. CD downloads. AI. Docker compose up -D. Cat desktop. Talk SQL. PG password. Equals secret. P SQL. U my user H localhost my database. Oh, friends. Last trick. Here we go. Make sure you export the port. Okay, one more time. That explains why I couldn't get to Zipkin. So we go back here and stop it yet again. Okay. There we go. Let's run this code for the 5th time. Okay, well, we got a response. I didn't print out the right result. Okay, almost there, though. So here we go. One more time.
Sorry.
Thank you.
Yeah.
Call dot content. Yes, okay, we have Prancer, right? It found the dog. Goodness, okay? So that's the idea behind RAG, is you're going to augment the response with the data from the database. Let's get going. Let's see, we're going to be very quick here. Chat memory, right? So I've just asked a question of the database. It searched the database, but as Dr. Pollack illustrated earlier, sometimes it doesn't remember this stuff, right? So let's change this a little bit. Let's ask it a very simple question. Chat client dot prompt dot user. Hi, my name is Josh. How are you? Sure, whatever, who cares, right? And then .call .content, right? So I'm going to print that all out, system out, and I'm going to ask the same thing again. And, what's my name? Right? Let's see does that look right?
Yep.
That should fail.
Well, it should not know who you are.
Right.
So something people get confused with in the beginning is when you start calling the API, it's stateless, whereas the ChatGPT web application is stateful, and it remembers what you said before, does the glorious string concatenation operator, and presents the previous things that you've said to it and the responses in the request.
Okay. Okay, I'm going to pass this in. We are running way behind, and the good doctor.
Yeah, maybe we do the last. This is the last one, or the observability. Maybe?
Yeah, IM. There's this, and then add that as well. Adding the advisors. IM. So now I've got that plugged in both, right? I've got a in-memory chat memory and a prompt chat memory advisor. I'm going to rerun same question now, and it's going to store things in this advisor using the RAM of my computer. There you go. Right. Okay. It now knows who I am. Congratulations. We just
one more person does.
Yeah. Let me see. We talked about functions here very quickly. Let's see. Get rid of that. What's the stat of my order? And then have a function down here. Function record order status request. String order number, and a response. Order status request, order status response. Hello. Look at that, order status. Okay, I'm just going to return, I'm going to integrate it with my local data, order status response.
To the system out.
Yeah, order is done or something. I don't know, whatever. And, oh yeah, we want a system out. Done. Okay, got
description.
That. Yep, description. Check order status. Not status. Don't worry, Doc, I got you. You're here in a second. And then I'm going to ask a question, right? So functions, this, and, well, that should work, right? Surely.
Mm-hmm.
Okay, I'm just going to tell it about this function that we just defined.
Give the number.
Oh, what is the status of my order? Order, number 1, 2, 3, 4, whatever.
See, so that was its reasoning. It knew that there was a function that took an order ID and then it asked for a happy accident.
And then finally, what is the observability story? Do I just? Oh,
I don't think we have time.
Okay.
I have to let Josh.
Gotta go. All that to say, you can now go to Actuator, go to see the metrics. You'll see how much tokens were spent. And you can go to Zipkin to see the distributed trace. Oh my God.
Okay, so what? Come on, wake up. Yep. So this demo that I'm going to give is actually on my GitHub. So Johnson R. And the demo is called Instrumented RAG. So what does this aim to do? It shows, I guess, something slightly closer to the real world, but building on the things that Josh demonstrated. So particularly how important and flexible advisors are and what I regard as some best practices. So one of the things that personally I would regard as a best practice is using Kotlin. I am never going to be one of these people that hate Java, but the fact is Kotlin is a really, really nice language. And when you combine Spring with Kotlin, it's a truly beautiful thing. And you realize that even with Java 22, the weak link is Java, it's not Spring. So, given that we're being very future-looking here and thinking about, Gen AI and where does technology go, I would encourage you to think about language. Second thing is that when you're getting started and doing stuff real quick, use the starters that Spring AI gives you. So, for example, if you use the Spring AI starter for OpenAI, you auto-magically get a model. However, bear in mind that a lot of real-world applications are going to want to mix models because we already saw how even with OpenAI, you can use different models for different purposes. So, for example, GPT-4o is the big model. It is really strong for really complex things. GP4o Mini would not be able to do some of those things, but it's probably 15 or 20 times cheaper, and it will do most of the things you want. Similarly, you might want to use local models as opposed to models in the cloud because you mightn't actually want certain things to go outside your firewall. The news about that is really, really good. Up till, I would say, 9 months ago or so, essentially for most things, OpenAI worked and nothing else really worked. So you could talk about model portability all you wanted, but the fact is, if you want the job done, you needed to use an OpenAI model. That is no longer the case. Obviously, Anthropic has arguably overtaken OpenAI, but open source models are getting good. So one of the things that I've done here is I have used 2 models. I've used the Ollama model and I've used OpenAI, but I have not used the starters. So I've imported the classes, but I'm going to have to create a bean if I want that to work. That means I can have multiple models. So let's have a look at the configuration class. So here, by the way, I'm using chat memory, which we already saw. I'm just using the in-memory one. But here I've got 2 chat models. So I've declared as primary the premium chat model, which is OpenAI. And I've also got a local chat model, which is an Ollama chat model. And I'm using Gemma 2b. That is a tiny model, a mere 2 billion parameters. 2 billion, it's nothing, absolutely nothing. It's about 1.6 gigs, and there are certain things it works quite well for. On the other hand, I have consisted, given that I only want to use one vector store, I have used the starter for Neo Vector Store. So I have a vector store bean, and with the wonder that is the portable service abstractions of Spring AI, my code doesn't know whether it's a Neo Vector Store or PG Vector or Pinecone or you name it. It just works. Okay, so what does this application do? It starts off with a Spring MVC controller, and here, if we look in our vector store, they will surface as documents in Neo, and we have no documents because I just deleted them. So let's turn the documents. There are no documents in that database. Let's now go to the instrumented chat, which is an HTMX page. I am creating a session that is giving it a unique name, so I did the cute Moby naming thing, so it's recursing sure. Okay, so hi there, I'm on stage. And what it's going to reply should have an interesting voice. Am I on the net? Oh, I'm on stage, I'm not on the network. Okay, let's see. I think I can hit my phone. Didn't think of... Josh, could you bring the brown bag closer? Okay, this is not good.
Okay, it's the...
It didn't...
Las Vegas Venetian?
I do, yeah, but it's not working here. Well, my phone should work.
I'd give you the connection from my laptop.
Sorry about this. This is not very good, but it didn't occur to me that I can't access the hotel Wi-Fi in here. Yep, I think I'm good. Okay, so what we're going to do is we're going to bounce the server, and we're going to, just to make sure everything's clean, and we're going to start again. And we're going to get amazing hertz. Hi there, I'm on stage. And so, yeah, hasn't complained yet. Hello there. The lights are bright. The audience are waiting. Give them your best, and remember, the moment is yours. Where did that come from? Let's have a look at the chat service. So here I'm using a chat client, and I'm creating a chat client specific for this session. So notice I've got message, chat memory, advisor. This is what Josh did. There's 2 types of that. This is the most important one. And I've also got the question answer advisor, which does RAG. I've put a couple of other advisors in there, and I've specified a session prompt. The session prompt is externalized into a resource, and it looks like this. So you're a helpful assistant, you speak in the voice of Ernest Hemingway. And best practice I would definitely suggest is always externalize your prompts never, ever put a prompt in code. One reason for that is when you externalize them and you look them up, you can steal other people's prompts. And there are a lot of prompts that the Python folks that have come up with that are really good prompts. So go and steal them. Obviously respect intellectual property, but there's plenty on GitHub that is ready to go. So always put your prompts outside of your code. Okay, so time is very tight. So I'm just going to explain a couple of things about what I've done here. So in the chat service, what are these? So these are standard out-of-the-box advisors. These are a bit like, Spring AOP interceptors. They're reusable. It's beautiful. I'm using the same chat memory advisor and the same question answer advisor that Josh did. So magically, I get memory, I get RAG. But I've written 2 others, and they are also reusable. And this, I think, is really quite cool. So one of them is the Capture Memory Advisor. What it does is the equivalent of the OpenAI. Have you seen the new thing in OpenAI where it creates a memory? It says memory recorded. It's just come in the last few weeks. So I'm doing that, and I'm doing that by making a different call to another model to extract the memory. So, for example, if we have a look in our documents in the database, match D document, we've got a document. In fact, we've got a couple of documents. So remember about about the user, I'm on stage. So it actually captured that twice. I'm not deduplicating. Notice here I'm calling the chat client to get a memory response, and I'm doing the entity thing that Josh did. I've defined this little data class. This, I think, is really good practice. You should very, very often talk to your LLM in JSON, and Spring AI will do the work of parsing the schema and doing that automagically. If you're in a strongly typed language like Python, like Kotlin or Java, the introspection will produce really nice schemas. So yeah, strongly recommend type your responses with things like that. So for example, if I now go and create another chat, this is if I do, so I've gone incognito. So where am I? It remembers that I'm on stage. How did that work? It worked because the memory has gone into the vector database. So I know I'm out of time. I'm just going to show you how that, just briefly walk through how that code works. So what it does is it's an advisor. It gets this advised request. It actually doesn't change it. At the end of it, it actually returns the same request, but it goes and tries to extract a memory, and it uses a different model. So this is using the cheaper chat model, totally local chat model, to analyze the text and extract the memory. And if it likes it, it writes it to the vector store. And just having a look at the application properties, something else I had to do is set the embedding dimensions in Neo to match the particular model that I'm using. So, hopefully takeaways from that: externalize prompts, use the chat client, it's awesome. Use advisors to reuse functionality across your code and other code, and write in Kotlin if you really want to enjoy the future. Thank you.
All right, amazing. Thank you so much to the 3 of you. What a treat. Okay. We've got a few minutes. So the next talk is going to start in 6 minutes, but we do have time for questions.
Yes, and a photo.
Oh, and a photo. Yeah, yes. Okay. Let's do. Anybody have questions? Okay, we have questions over here. So let's take a first question.
When you were using the vector database, you basically stuffed all the the dogs themselves into the query, right?
Yep.
How do you handle when the database is huge, that crosses the 100,000, size of the context?
Yeah, that's the beauty of vector databases, is that you can stuff it, with millions, billions of documents, and it will be very efficient in returning just a subset that's relevant. So it's kind of like you can write one in an afternoon, but you can't write a scalable one in an afternoon, which is why you have to go to the companies that specialize in that.
Awesome. All right, we have a question over here.
Thank you.
Sorry.
First, thanks for the presentation. It
You're
was
welcome.
lovely.
Thanks for coming.
Thanks for coming.
But what's your opinion
Little
on...
close.
Okay, sorry. What's your opinion on the lack of explainability in the OpenAI models? We have correlation without provable
Trust
causation.
us. We're a doctor.
I think that
I think people are going to just get over it at some level, and they'll have tracing in their app. But I think it's up for the real, researchers to have explainability built into the models on the server side. That's, I think, where the true answer will come, right? The sequencing of calls that we make, we can explain, right? I took this if statement or that if statement, and went down different branches. But I think right now it's just, it's a black box, and hopefully as generative AI technology gets more sophisticated, like adding functions, it'll add explainability, as a feature.
I'm a little more
That's
skeptical about that.
My view, but clearly this is not a settled question. Yeah.
My take on it is I think a lot of it, at least in the foreseeable future, is going to have to come from the client and from orchestration. And remember that RAG gives you explainability. So it enormously enhances your explainability. So why did the model say that Josh's order was done? Well, we can prove why the model said that because we can log what we sent up to it. So, RAG already gives you a great degree of explainability and also function calling to some degree. Like the value that came back from the function, that's like a normal system. But I do think that there is a lot to be said for breaking apps up into lots of smaller calls rather than big God calls, and that helps a bit as well.
One of the things I loved, by the way, you did a great demo showing all these things pulled together, but you also used Spring Data Neo4j, which is the first Spring Data project that was ever created, that you created in the Spring Data project. You used portable service abstractions. You had a thing like AOP or interceptors, whatever. We have a lot of things that look like that.
Mark did that.
Oh, you did that? Yeah. Well, either way, it's this all this new stuff, very much sort of in the spirit of and the style of what you know of in the Spring ecosystem.
We also didn't get to show the bit that publishes an application event. Like I wrote another advisor that basically listens for mentions of Spring, and if any user mentions Spring, it publishes an event that can be handled elsewhere in the application context.
Yeah. Out of band.
So that repository, by the way, it's Johnson R and it's instrumented RAG with a hyphen.
Yeah. I have a question. Who learned something new? All right. Who had fun?
Good times.
All right. Good. I had fun.
One more smile for
Oh yeah, smile. Feel like you're happy. Come on, guys. Come on. 2 docs and adult.
Perfect. All right, amazing. Thank you guys so much. That was
Thank
wonderful.
you.
Really wonderful.
Thank you. Thank you, sir.
Yeah.
I learned a lot as always.